We are working on a Maytag-Whirlpool built electric dryer today. The complaint is that when you put it onto a cycle and press the button, nothing happens. But the other thing that's going on, curiously, is the customer reported that they feel heat, and you definitely feel heat coming out from the inside of the drum, even though nothing's going on. We look at it back here. I've got the back off already. Look at the heater, glowing nice and orange. Nothing's going on in the drum. So we're going to look at, I'm going to turn this off right now. We're going to look at why that is. Now you see the heater going off. Now that I've put the timer back on off, the heater is not glowing. We're going to take a look at the schematic here in just a second and see electrically how is this possible for the motor to not be running and the heater comes on when the dryer is plugged in and the timer is moved to some position other than off. All right, so let's look at the schematic here, and we're going to see how electrically, just looking at the schematic, how is it possible to see what we were seeing on this dryer. Here's L1, get a little closer, and over here is the heating element. So L1 comes down through this set of timer contacts, through the thermal cutoff and the operating thermostat and the high limit to this side of the heater. L2 has to come through the motor centrifugal switch, so it's only going to be made when that motor is running for this switch to be made over to the other side of the heater. That's the heater's intended circuit. But what would happen if part of the heater coil was physically broken and contacting the grounded case on the heater coil, so that case that the coil is in? Well, then we would have L1 come in clear over to this side, and you have the timer on, clear over to this side, and then you would have a return path. You would since the coil is touching the case of the heating element, and that case is grounded. It's also in this case a 3-wire connection, so it's bonded to neutral. So then we've got a complete circuit. So in other words, the part of the heater coil that is up until the point that it's broken and it's contacting the case is getting 120 volts, not getting 240 like it was intended to get by design, L1 to L2 240. Instead, it's going to be getting L1 through the timer contact, through the controls, to ground/neutral in this case, which is 120. That's why the heater can glow whenever the timer is moved to a position other than off. How is it then that the motor is not running? Look here in the motor circuit. Thermal fuse. So, which means that the thermal fuse probably blew because the heater was always on. Thermal fuse did its job, prevented the motor from running. Didn't cut out the heater, but definitely alerted the owner to a problem. And so we are going to then, and I'm going to show you what a grounded heater looks like, how to test for that. We're going to actually put a meter on it and check and see that, yes, indeed, one of the coils on the heater, one of the broken ends of the coil is actually contacting the case that the heater is in. And then we're going to do a continuity test on this thermal fuse. So we're going to bear out all of this wonderful theory. Okay, so here we are in back, and we're looking at those two key components. The heater's right in here, and here are its power terminals down here, and here's its high limit. There is also the thermal fuse right here, and it's connected here. So we're going to check both of these guys. Take a wire off the thermal fuse. I already had it loosened, and I'm using my Fluke electrical tester here, and we're going to then put my probes right on here, checking for continuity. This particular meter is capable of doing continuity, and I'm looking. I got nothing. Here, I short my leads together. See, it does continuity, beeps and lights up at me. I'm right on the terminals of this, so we have an open thermal fuse. That bears out one part of my theory. Now, the other part of the theory. So here's the power wires for the heating element. And by the way, we are unplugged. I didn't show that, but obviously I wouldn't have my hands back here if we were plugged in. So, and these are the two terminals here, not this orange one, these two metal terminals here. So again, we're going to check. So yeah, it seems like a good heating element, but that part's okay. What is not okay is when I touch the case here. There should not be continuity. This case is just there as a sheath. The fact that these tabs are connected to the coil inside here, the fact that I'm getting a current path from one of the power connection tabs to the grounded case of the element means that the coil is broken, and it is providing a path for current from L1 to neutral. So that's what we have going on here. We have a bad heating element and a bad thermal fuse. Both of these will be replaced and harmony restored.